that says isotopes. So you've heard about isotopes, but what exactly are they? You probably know that atoms have a dense nucleus made up of positively charged protons and neutral neutrons, and that the nucleus is surrounded by a bunch of negatively charged electrons. Isotopes are atoms of the same element, meaning to have the same number of protons and electrons, but that have different numbers of neutrons. The different numbers of neutrons give isotopes different masses. Back in the early 90s, the discoverers of the electron, J.J. Thomson, with the help of the student Francis W. Easton, identified two different types of neon atoms. One type with 10 protons, 10 electrons, and 10 neutrons, and then one with 10 protons, 10 electrons, and 12 neutrons. Aston went on to invent a groundbreaking machine that he called a mass spectrograph. Using this machine, Aston identified hundreds of other isotopes of other elements. The mass spectrometer is now used in labs all over the world, and Aston won the 1922 Nobel Prize in Chemistry for his work. These are the isotopes of neon that Thomson and Aston saw. The numbers you see here tell you the total number of protons plus neutrons in each atom, and they also tell you the isotope's approximate mass. Technically, the mass of an atom would include protons, neutrons, and electrons, but since the mass of electron is almost 2,000 times less than that of protons and neutrons, we can basically ignore them. When it comes to atoms and their behavior, there is an important distinction to make between chemical reactions and nuclear reactions. Chemical reactivity is defined by the electrons that atoms possesses. When atoms come into contact with one another, it's the outer electrons that interact and determine the type and the intensity of the reaction. Since isotopes of a given element have the same number of electrons, they will undergo similar reactions. On the other hand, nuclear reactions rely on the particles in the nucleus. So, different isotopes will undergo different nuclear reactions. Because of the differences in the makeup of their nuclei, so what happens in a nuclear reaction? Basically, something changes in the nucleus, because the nucleus is made up of protons and neutrons. You might think that all of those positive charges crammed together and repelling one another would make the nucleus unstable. Luckily, there is a force known as the strong nuclear force that acts as the glue that holds the whole thing together. But when the nucleus of an atom contains lots of protons and neutrons, or when certain neutrons to proton ratios exist, even the strong nuclear force can't hold it all together, and the whole thing can become unstable. When that happens, the atom's nucleus will either kick out some particles or rearrange itself. Typically, one of three things happen. Alpha decay is when two neutrons and two protons are kicked out of the nucleus to form two different species, a helium nucleus and a totally different element than the one we started with. In this case, uranium ejects the alpha particles and becomes thorium. In beta decay, a neutron splits into a proton and an electron, and the electron is ejected from the nucleus. Because this changes the number of protons in the nucleus, a new element is formed. In this case, thorium becomes protactinium. Gamma decay is when protons and neutrons in the nucleus are rearranged to reduce the energy of an unstable atom. This rearrangement comes with a release of energy in the form of gamma rays. This time, since the number of protons in the nucleus stays the same, no new element is formed. These spontaneous changes in nuclei are known as radioactivity. While radioactive substances can be hazardous, in some cases, they can also be incredibly useful. They give us an accurate way to tell how old things are. They can be used to detect